So let's take an example where we use both timers and counters. Let's design a system where a parking lot has 10 spots. Whenever a car comes in, a sensor detects a car and the door opens for 3 seconds. The 3 seconds are used for demonstration purposes. In real life, 3 seconds is really short to keep the door open, so let's keep it for 3 seconds for programming purposes. A green light is showing that there are some spots left in the parking lot, and a red light that's showing there is no spots left when the parking is full. The first part in the inner problem, let's try to identify the inputs and outputs of the system, and I mean the physical devices. So the car sensor is an input to the system. The parking lot door, the green light, and the red light are output to the system. The first thing is that once the car comes in, detected by the sensor, the door opens. So we are going to use an XIC instruction for the car sensor, and for the door, we use it as an output. Now every time the door opens, it stays on for 3 seconds. So now we need a timer. As soon as the sensor detects a car, the door opens for 3 seconds. For the 3-second timer delay, we need to add a timer on delay to keep track of the time. And if we select the base to be 0.1, then the preset value is 30. Now the program works this way. As soon as the sensor detects a car, the timer starts timing. So now I need to add the parking lot door so the door stays open for 3 seconds. Remember that we have 3 status bits for the timer, so I need to select the bit that the door opens while the timer is timing. So in this case, we are going to select timer timing bits. Now, as soon as the car comes in, a sensor detects the car and the timer starts timing for 3 seconds. And during that time, the door opens and stays on for 3 seconds. As soon as the timer reaches the preset, which is 3 seconds, the timer timing bit goes to false and the door closes. The second part of the problem is that we need to keep track of how many cars gets into the parking lot. So now I need to use a counter. We are going to use a counter up because we're counting how many cars gets into the parking lot. For the preset value, we are going to use 10 because we need to keep track of 10 cars. The counter name is going to be car counter. There's a good practice in programming is to choose a name that's related to the task. Now every time the door opens, the counter counts by 1. Remember that the counter counts in the transition from false to true. Every time the door opens, the counter incremented by 1. And we place this after the second rung. Now the program works this way. Once the car gets in the front of the parking lot door, the car sensor senses the car and the door opens for 3 seconds. And once the parking lot door is activated, the counter increments by 1. Remember again that the counter counts in the transition from false to true. Let's continue programming. Once there are available parking spots, there's a green light that needs to be turned on. So we are going to use the counter to achieve that task. As long as the counter is not yet done counting, in other words, as long as the accumulator value is less than the preset, a green light is on. As you learned before, the counters in PLC come with bits that are associated with them, counter up, counter down, and done bits. Since I want the green light to be on while counting, and while the accumulated value is less than the preset, the bit that I'm going to use is counter up bit. So now, as long as the accumulated value is less than the preset, a green light will turn on, indicating we have enough spots for parking. So this is how the logic looks like so far. Now, the last thing is that when the parking spots are filled, once there are 10 cars inside the parking lot, a red light turns on, indicating that there's no more parking spots available. Again, we are going to use the counter instruction. Once the accumulated value reaches the preset, the done bit is now true. So we use the done bit and connect that to the red light. The program now behaves this way. While the counter did not reach the preset, the counter up bit is active and a green light is on. Once the accumulator reaches the preset, the counter up bit is not active anymore, so the green light turns off, and at the same time, the done bit is activated and a red light turns on. So this is the solution for this specific problem. In other cases, we might need to keep track of the cars coming in and leaving out the parking lot, but this is the complete program for the example that I'm using in these slides.